Welcome to this general induction to research labs in the School of Engineering. This course has three main objectives: to outline the School of Engineering's expectations of the way lab users should work in the research labs, to familiarise lab users with safe working practices in research labs, and to instruct lab users in how to contribute to sustainable research practice by minimising the environmental impact of their work. All of the content in today's training is contained within the school's Research Labs Handbook. This document is a policy guidebook for research labs, and you should take your time to read it carefully. It is publicly available on the school's wiki pages and the School of Engineering Sustainable Labs Microsoft Teams channel. If you are not a member of this Teams channel, please email the Research Labs Technician Team mailbox stating which lab you work in, and one of the Research Lab technicians will add you. It is a requirement for every experiment or procedure carried out in the research labs to have an associated set of safety documents. In the School of Engineering, we call this collection of documents the lab passport. There are usually three types of document associated with a single experiment. The pre-start form outlines the procedure to which the documents refer. This is effectively your experimental protocol. The risk assessment outlines the key hazards, that is, anything that has the potential to cause harm, associated with a process or experiment, and what control measures are put in place to minimise the chances of a person coming to harm as a result of those hazards. Risk assessments are living documents. If your experimental method changes, you should update your risk assessment to reflect this change. Finally, each hazardous material handled in the experiment must have an associated COSH form. This is a legal requirement for any hazardous material handled in a workplace in the UK. You should use the safety data sheet supplied by the manufacturer as your main source of information for the COSH form, and then write the COSH form in the context of how you intend to use the chemical. COSH forms should also be reviewed at least annually to ensure that there are no changes to the way a chemical should be handled. Detailed guidance on how to fill out all of these safety documents can be found in the Research Labs Handbook. There are some general safety rules that should be followed in research labs at all times. You should not eat or drink in a research lab, and this includes chewing gum. Eating or drinking increases the risk of ingesting harmful materials present in the workspace. You should also not use headphones in a practical workspace, as this reduces your spatial awareness, making you less aware of hazards around you. You should also always walk to reduce the chance of dangerous collisions with equipment or other lab users. You should also keep main thoroughfares clear to allow people to move freely around the lab space. Many of the experiments carried out in research labs involve some kind of interaction with hazardous materials. Hazardous materials are most easily identified by the red diamond-shaped labels on them, known as Globally Harmonized System or GHS labels. You should take time to familiarize yourself with what these symbols mean. You will find that if you complete COSH forms to a high standard, then you will also be familiarizing yourself with the key hazards associated with the materials you are using. You can find a helpful summary of what each symbol means in Chapter 3 of the Research Labs Handbook. The school needs a good awareness of the hazardous chemicals it has in its labs, and it is everyone's responsibility to ensure that these materials are being appropriately stored. When you buy a new chemical, you should ask a technician, experimental officer, or lab manager based in your lab where you should store the chemical. This is to make sure that incompatible materials are not stored together. You must also write the name of your PI and the date you opened the bottle clearly in permanent marker on the side of the bottle. This helps people to identify when a chemical is out of date and should be disposed of. Winchesters are large glass containers used to store large volumes of liquid chemical. Transporting Winchesters must be done safely to prevent them from being dropped and causing large chemical spillages. Winchesters should always be carried in a wire solvent carrier like the one in this picture. If your lab does not have one of these, please speak to the technical manager for research and they will arrange for one to be purchased for your lab. In the School of Engineering, we are committed to using our resources in the most sustainable and cost-effective way. Because of this, we try to share chemicals between research groups and labs as much as we possibly can. If you need a chemical that does not exist in your lab, check the school's chemical inventory on the Sustainable Labs Teams channel or the school wiki to see if the school has it elsewhere. If we do, email the Wet Labs technical team who are responsible for chemical stocks, and they will arrange for you to borrow the chemical if this is possible. Over the course of your research project, you will likely generate research samples. Research samples can take many forms. They could be a novel material you have prepared in the lab, or they could be environmental samples that you have taken from working in the field. For example, samples of concrete from a building site. These samples must be labelled in such a way that they can be easily identified by both yourself and other lab users. Unlabelled research samples are safety hazards, as other lab users must assume that they are hazardous. If you leave the university and you have left unlabelled research samples in your lab, they must be disposed of as unknown hazardous waste. This is very expensive for the school and has a high carbon cost environmentally speaking. As a minimum, your research samples should have the following information clearly written on the container they are in. Your full name, not just your initials, the date on which the sample was prepared, and a way of identifying what the sample is that can be understood by other lab users. The School of Engineering is committed to reducing the environmental impact of its research. The university as a whole supports the Sustainable Development Goals set out by the United Nations. As part of this commitment, the University of Edinburgh is a signatory of the UK Concordat for the Environmental Sustainability of Research and Innovation Practice. This is an agreement between universities and funding bodies to improve how sustainably the academic research sector in the UK operates. In 2025, the School of Engineering is demonstrating its commitment to this promise by working towards a silver award in the university's Sustainable Lab Awards scheme. We all have a responsibility to support this initiative by the way we work, by considering simple things like how we use equipment that uses energy and water and how we dispose of waste. This section of the presentation will focus on the policies in place in the School of Engineering that help to reduce our carbon footprint and the simple ways in which you can play your part. We try to save energy by leaving equipment switched off as much as possible. Equipment in our labs and light switches are labelled with stickers instructing lab users to switch them off when not in use. Please note that some equipment cannot be switched off, as it is either in constant use or switching it off is not feasible. This is indicated by a red "Do not switch off unless authorized" sticker. We also have unattended experiment cards, which should be filled out and placed next to an experimental setup if you plan to leave it on for a number of hours or days unattended. This indicates how long the equipment needs to be on for, thus minimizing the amount of time it is left on. Fridges, freezers, and ultra-low temperature freezers use significant quantities of energy. One of the best ways an individual lab user can keep this energy usage lower is by ensuring that freezers are fully packed out. Maintaining low temperatures in cold storage is aided by increased thermal mass, in other words, more solid material in the same space. Free space allows warm air to better enter when doors open and accelerates the warming up of samples. Similarly, solid materials maintain cold temperatures much longer than air itself, reducing energy consumption by the freezer. There are two ways in which you can do this in a freezer. Use racking and/or boxes to appropriately organize samples and efficiently use space, as demonstrated in the picture, and use polystyrene boxes or ice packs to fill up unused space. Technicians and experimental officers defrost and clean freezers at least annually to ensure that they work as efficiently as possible. If you spot a freezer that desperately needs defrosting, contact the technical manager for research who will arrange for the freezer to be attended to. Wasting water is very common in research labs. There are some simple things we as lab users can do to improve this. If you are setting up a system that uses water as a coolant, you should try to use a water chiller instead of connecting the system to the tap. Also, make sure that large water-using equipment such as glass washers and autoclaves are full before switching them on. This reduces the number of runs they need to do. Water baths should have lids on them that prevent water loss due to evaporation. Finally, if you spot a leaking tap, report this to the school's buildings team straight away. Speaking of the school's buildings team, they are responsible for looking after essential laboratory infrastructure and utilities. This includes lighting, water supplies, ducted fume cupboards, Needham arms, and heating, ventilation, and air conditioning systems. Faults with such infrastructure can waste a lot of energy. For example, a blocked ventilation duct will cause the fan that keeps the air flowing through that duct to need to work even harder to get the same airflow. Because of this, it is important that lab users report infrastructure faults as soon as they notice them. The easiest way to do this is to send an email to the local school's buildings team at buildings.eng@ed.ac.uk giving a description of the issue. Fume cupboards use significant quantities of energy. There are a few things you can do to reduce the amount of energy they use. Firstly, ensure that any equipment you set up is at least 15 centimetres from the front of the fume cupboard. This allows the air to flow without obstruction, meaning that the fans do not need to do more work. You should also keep the lab door closed when using a fume cupboard. If your fume cupboard is recirculating, you should be able to switch it off when it's not being used. If the cupboard is ducted, you should close the sash so that the fume cupboard is drawing the least amount of air through. Ducted fume cupboards in the School of Engineering have these stickers on them. The fume cupboard is fully closed when the two halves of the sticker meet to form the full picture. If you are uncertain of how your fume cupboard works, speak to a member of the technical staff and they will show you how to use it properly to ensure your safety and the efficiency of its use. Research labs generate a lot of waste. In the School of Engineering, we are working to reduce the carbon cost of the waste that we generate by streamlining our waste streams and reducing the amount of waste we actually generate by reusing items. However, because we generate a lot of waste that is considered hazardous, we must also consider the safety of those who handle such wastes and the potential environmental impact of accidental release of those hazardous materials. Because of this, laboratory waste that has been contaminated with a hazardous material must not go in a regular bin or down a drain. We separate the solid wastes we generate to allow some of it to be recycled and also to ensure that hazardous wastes are not handled by non-lab personnel. Some wastes, like hazardous waste, have a very high carbon and financial cost, so we try to minimize what we put in these waste streams. For example, if you wash your hands, the paper towels that you use should go in the general waste, as this has a lower carbon cost than hazardous waste. However, if you use paper towels to wipe up a chemical spill in your lab, this should be treated as hazardous waste. You should ask your technician or lab manager to show you the different solid waste streams for your lab and what wastes should go where. If your lab generates a lot of hazardous liquid waste, it should have a liquid waste holding area like this one. Make sure that you consult with your technician or lab manager about how to dispose of your liquid wastes. Some wastes are non-hazardous and can go down the sink in the lab, but you need to consult with an expert to be absolutely sure if you can do this. This is the most important thing you should do when dealing with any waste. If you are unsure of what you should do with your waste, ask. As stated before, more detailed guidance on how to work in research labs can be found in the Research Labs Handbook, which can be found on the School of Engineering Sustainable Labs Teams channel. There are also a number of other resources in this channel which you may find useful. For example, there is a copy of the school's chemical inventory that you can browse to see if you can borrow a chemical instead of buying it. If you are not a member of the Sustainable Labs Teams channel, please email the Technical Manager for Research and they will add you to this. Thank you for taking the time to watch this short Research Labs induction presentation. If we all follow the same simple guidelines for working in research labs, we can ensure that our workspaces are as safe and sustainable as they can be. If you have any further questions regarding the content of this course or anything else related to working in research labs, please contact the Technical Manager for Research or your local lab technician.